you must know about input-output ports of PLC. Ever wonder how machines think? How do they know when to start a motor, stop a conveyor, or trigger an alarm? Well, my friends, welcome to the world of PLCs. Today, we're diving into the brain of industrial automation, the PLC, and understanding its key components. Input-output ports, power supply, communication modules, and of course, the almighty CPU. Traditional old factory system versus a modern PLC-based control system. Before PLCs, factories relied on bulky relay-based systems. It was like using an old-school switchboard to control machines, messy, slow, and difficult to troubleshoot. Then came the PLC, a compact, programmable device that makes automation smarter, faster, and way more efficient. Every PLC needs power to function. Most PLCs use 24 VDC or 230 VAC to operate. Why 24 VDC? Because it's safer and prevents electrical damage. Pro tip: always check the power supply voltage before connecting a PLC. Wrong voltage equals boom. Collision.
A PLC consists of a computer with several additional hardware pieces that are a part of it or can be attached to it at any time. Today's PLCs have replaced much of the old-style hardware circuitry in industrial applications, but many of the original physical devices are connected to the PLC. The hardware components of a PLC are the processor, the power supply, the input-output modules, and a programming device. The AC mains connected power supply provides DC power for the PLC modules, but not for field devices. The input-output modules are connected to digital or analog field devices. The processor consists of the CPU, or central processing unit, and memory. The programming device in today's industrial applications is usually a laptop or a desktop computer.
Now, meet the CPU, Central Processing Unit. This is where the magic happens. The CPU executes the program you write, processes inputs, and sends commands to outputs. Think of it as the brain of a robot, making decisions 24/7. Loudspeaker quick fact pop-up. Higher-end PLCs have faster CPUs and more memory. The inputs are like the PLC's eyes and ears. They sense what's happening in the field. These come from sensors, switches, push buttons, or any other signal-giving device. In a PLC, inputs receive signals from sensors, and outputs send control signals to devices like motors and valves. Digital inputs and outputs, DI/DO. Digital inputs work with on-off signals, like push buttons and limit switches. Outputs work the same way. Turn devices on or OFF. They usually operate at 24 VDC or 220 VAC. Analog inputs and outputs, AI/AO. Analog inputs handle continuous signals, like temperature or pressure, typically using 0-10 VDC or 4 to 20 milliamperes. Ever wonder how a PLC talks to SCADA systems, HMIs, or even other PLCs? That's where communication modules come in. Common protocols include Pushpin Ethernet/IP, fast and used for networking multiple PLCs. Pushpin Profibus and Profinet, popular in industrial automation. Siemens loves these. Pushpin Modbus, universal and used in many industries.